Have you ever wondered how rockets work in space where there is no air to push against? It's an intriguing question, isn't it? How does a hunk of metal, fuel, and human ambition defy our earthly understanding? It's quite a fascinating process. Let's dive into it. Scene script. Space, a vacuum with no air or wind to push against. So how does a rocket move forward? Well, it all comes down to a fundamental concept of physics known as action and reaction. It's like when you blow up a balloon and let it go without tying it. The air rushes out one end and the balloon zips off in the opposite direction. That's pretty much how rockets work too. Rockets carry their own fuel, which is a combination of a substance to burn and a source of oxygen to let it burn. When the fuel ignites, it creates a high-pressure and high-temperature gas that rushes out from the rocket's engines. This expulsion of gas generates a force in the opposite direction that propels the rocket forward. This is nothing but Newton's third law of motion at play. For every action, there's an equal and opposite reaction. In simpler words, rockets throw stuff out the back and move forward. So, what's this stuff that rockets throw out? Well, that's what we're about to discover. The fuel in a rocket is the key player in its journey to the stars. Rockets can use either solid or liquid fuel. Solid fuel is often used in the initial stages of a launch, while liquid fuel is typically used once the rocket is in flight. When ignited, the fuel combusts, creating a high-pressure and high-temperature environment inside the rocket engine. This combustion process generates hot gas. But here's the interesting part. It's not the gas itself, but the action of the gas being expelled out of the rocket that creates the thrust needed for the rocket to soar skywards. It's like blowing up a balloon and letting it go. The air rushing out of the balloon propels it forward. Similarly, the rocket is propelled forward by the expulsion of hot gas. Fuel, in essence, is the powerhouse of a rocket. Now that we know what propels a rocket, how does this thrust work, you might ask? Well, it all comes down to the third law of motion, famously stated by Sir Isaac Newton: for every action, there is an equal and opposite reaction. In the context of a rocket, the action is the expulsion of gas downwards. This action creates an opposite reaction, which is the force that propels the rocket upwards. This force, my friends, is what we call thrust. So how does it work? Picture the rocket's engine combusting fuel at an incredibly high rate. It spews out hot gases downward at tremendous speeds. As these gases rush out, they push against the rocket, creating an upward force. This force is strong enough to overcome the pull of Earth's gravity, propelling the rocket into space. Imagine thrust as the invisible hand that pushes rockets skyward, defying the gravitational pull of our planet. That's the power of thrust, pushing rockets against the pull of gravity. So, in a nutshell, how do rockets work in space? Let's rewind a bit. Remember, it's all about Newton's third law. For every action, there's an equal and opposite reaction. When rocket fuel combusts, it creates a forceful expulsion of gases that propels the rocket in the opposite direction. The lack of air in space doesn't hinder this process. Instead, it eliminates air resistance, making space a perfect playground for rockets. The heart of the matter is thrust, the force that overcomes gravity and propels the rocket upwards and onwards. This combination of physics, chemistry, and a dash of ingenuity is what makes space exploration possible. There you have it, the marvel of rocket science in a nutshell.